Example, set up the definite integral that represents the shaded area or areas over the given intervals. We have graphs of two functions drawn in the first and second quadrants. A is marked on the negative x-axis, B, C, and D on the positive x-axis. The graph of y equals f of x is a positive slope line drawn with dashed lines from the second quadrant rising through the first. The graph of y equals g of x is the solid curve that is an upward open arc also drawn in the first and second quadrants, but primarily in the first quadrant. The two graphs intersect at x equals b and at x equals c. Part A, on the interval from b to c. We note on the graph that the interval from b to c, the line y equals f of x is above the curve y equals g of x. We would write the integral as the integral from b to c of f of x, that's the top line, minus g of x, the bottom curve, dx. Part B, interval from a to b. On the interval from a to b, the arc is above the line. And so we would write this as the integral from a to b of g of x, which is the arc, minus f of x, which is the line, dx. And now on to part C, the integral from b to d. Let's observe that two things happen. From b to c, the line is above the arc, so we have the integral from b to c of the line f of x minus the arc g of x dx. We also need to add from c to d, and in that interval the arc g of x is above the line f of x, and we write that as the integral from c to d of g of x minus f of x dx. The crucial takeaway from this example is when you set up the area between curves, make sure that you have the top function minus the lower function.